Hello everyone, my name is Finding Pepper and welcome to episode 2 of the 3D tutorial. Last episode we created a system which could render 3D blocks arranged in a grid. This episode we'll be adding textures to those blocks, so their faces will no longer just be one single color. But before we do that, we need to do some optimization and cleanup. Because right now at high quality resolutions, the game is virtually unplayable. It's just way too laggy. Now first I would like to just do some cleanup. There's one thing I'd like to do, and that's just to eliminate the block size variable. We don't actually need it. Let's just try real quick setting block size to 1. That means we will need to turn down the view distance to something like 8, because if the block size was 1, a view distance of 100 would mean we'd be able to see 100 blocks, and that would definitely be laggy. Now on our move camera, when we change our camera variables, rather than multiplying these by 5, I'll change these to division. So I'm going to divide each of these by 5. And just a quick note, you'll notice I was able to change these by right-clicking on them, and I have a pause button and things like that. You'll notice there's an add-ons button at the top. If you just click on this, then you'll be able to configure some additional helpful tools. So I'd highly recommend going through here and checking out that. You can get those for normal Scratch as well. It's just a browser extension. Oh, and we'll also set camera Z to, rather than -50, we'll make it like -2. And finally, in our look forward block, we'll make this move forward a resolution divided by 80. 5 times 16 is 80, so this is just moving forward the same distance relative to the block size as we did before. Now if we run this, everything should behave as it did before. And it looks like it does. Now we can just go through all the places where we find the block size variable, and we can just remove them. So when the flag clicked, in our place block, we'll replace these by, it's just a X, Y, and Z without the times block size. Get grid at X of position. We'll just make these floor of X, floor of Y, and floor of Z. In our check collision at, we'll just make these less than grid width, less than grid height, and less than grid depth. And that should be it. We can now delete the block size variable. Let's just run this once again to make sure it's still working, and it looks like it is. Alright, now for our optimizations, the first thing on our list, let's take a look at the move forward by amount block. And you'll notice when we're changing X and Y and Z, amount could change, but the rest of this stays constant throughout our entire array. So rather than calculating this whole thing every time we move forward, we can just store it in a variable. I'll call these change X, change Y, and change Z, all for this sprite only. Just grab out one of these, set change X to, then I'll get some pluses. We can put what we multiply amount by here in our first change X to one of the plus inputs. Then what we multiply amount by in our second change X, we'll put in another plus. And then again what we multiply our amount by in our third change X, we'll put in our final plus input. So we have a big long equation here. Make sure you just got everything from our change X's. Now we can delete 2 of these and just change X by amount times change X. We'll do the same for our change Y. I'll set change Y, and I'm not attaching these blocks to anything yet. I'm just keeping them here. Then we'll get another plus. This one's a bit simpler. It's just what we multiply our first amount by, and then what we multiply our second amount by. Then for our change Z, and then this will be, again, just exactly what we did with the other two. So just be careful that you dragged everything correctly. With our Y's and Z's, we'll also delete the additional changes, just leaving 1. Then do the same as we did with the X, changing by amount times change Y and amount times change Z respectively. We can then put our set change X, change Y, and change Z blocks in our create camera view block before we look forward. If we run this, everything should work exactly the same, and it appears to be. I'll put the formulas right here. If it's not working, you can pause the video and just look over these. Now we can do some optimizing. Let's look at our look forward block. Here we are moving forward quite a bit, by which I mean we're moving forward quite a lot of times, and we would like to be able to minimize the amount of times we move forward. So we need to maximize the amount that we move forward by each time. So let's look at this. Pretend this is one of our blocks. Again, this is a 2D representation, but this is where we start casting the ray from, x, y. We can actually move all the way along our ray until we just get outside of this block. So right where it intersects the white line. And we want to find the amount that we can move to get to that point. So to find that amount, let's look at what we know. We know the x and y coordinates of the edges of the square. These are the floor of x and y respectively, and the ceiling of x and y respectively. And this works because we set our block size to 1. Now we can look at amount. Turns out that amount is equal to, in this case, d, which is the ceiling of y, minus y, so the vertical difference, and then we can divide that by our change y variable. Because remember, when we move forward by amount, we're changing our x, y, and z variables by amount times change x, change y, or change z. So if we divide by change y here, then this multiplied by change y will just be d minus y, which is the top of the block. But how do we know that d and y are the variables we want to look at? How do we know, say, we don't want to be going all the way to the right edge, which I'll call the full distance of the red line here, amount 2. So amount 2 is c minus x over change x. And the reason we know we want amount rather than amount 2 is because amount is less than amount 2. So we want the least distance to move, because that way we can ensure that we don't overshoot any blocks. Now what if, rather than moving upwards, we move downwards or to the left? Then we'd want to have b minus y, the floor of y minus y, so the difference between our point and the bottom. And this occurs if change y is negative, and similar for change x. So if change y is positive, we want to subtract y from the ceiling of y. If change y is negative, we want to subtract y from the floor of y. Now we can try to code this. This is essentially the same in 3 dimensions. So in our look forward block, inside a repeat until loop, we will make a variable called amount for the sprite only, and this will hold that amount that I was talking about. I'll just move out the move forward and change dist and all this in here outside of the loop. We'll add that back later. So let's start with an if else. If change x is greater than 0, then we'll set amount to the ceiling of x minus x, just like we talked about, and then we divide this by our change x variable. Now in the else, I'll get another if else. If change x is less than 0, then we'll change the ceiling to a floor. Now in the final else, if change x equals 0, we'll never actually hit anything, so we can just set amount to a large number, say 9999. Now for our change y, we don't want to overwrite the amount variable because we don't yet know which of these is the smaller. So I'll make another variable called amt2, amount 2 for the spread only, and I'll set that variable here. Of course, we need to remember to change our change x's to change y's, and our x's to y's. Great, make sure you've got everything switched over, don't have any lingering x's sitting around, that would be bad. Now once we have both amount and amount 2, we can compare them. We'll say if amount 2 is less than amount, then we'll set our amount variable to amount 2, because this way the smaller one becomes our dominant amount variable. Finally, our change z, just make sure to get all the y's and change them to z's. Again, make sure you didn't miss any y's. They're all z's. Okay. Now we can duplicate this. If amount 2 is less than amount, set amount to amount 2. So we want to do the same thing here. So by the end of this, the amount 1 will be set to the smallest of these. Now then we can move forward by amount. And change dist by amount. However, if we just move by amount, depending on the direction we're moving, we might not actually get into the next block over. So we need to just add a small number, 0.02 001 to this amount, just to make sure that we get to the next block. If we don't add this, there is a chance that we get stuck in an infinite loop because amount could become 0. And now, finally, in the move forward block, we don't need to round our x, y, and z's anymore. I did that just to make the edges of the cubes a bit more straight, less wavy, but now we've got our x, y's, and z's variables pretty well defined, so we don't need to round them anymore. And in fact, rounding them could put them over the line into a different block than they're supposed to be in. Now we can run this and see if it works. Moment of truth, and yes, it does appear to be working. It does appear to look exactly the same as it did before, which is just what we want. Let's try setting our resolution to a higher amount, say 5. And now, yes, it's definitely laggy, but it's much faster than it was before. I'm going to settle with a resolution of 6. Alright, now that we've done that, we can actually go ahead and add our textures. Now we need a way to get our textures onto the surface of our blocks. And to do that, we're going to need to find the colors of all the pixels on them, and then display the color of the respective pixel that our ray hits. To find the colors of all the pixels, we'll need to use image scanning. So head over to the Scratch project. There will be a link to it in the description. This is a scanner made by Griffpatch, and he has a tutorial for it, which I would highly recommend going and watching either now or when you're done with the video. But anyway, once you get to the project, find the scanner sprite and right-click on it and click Export. We can't use our backpack because it doesn't carry over into Turbo Warp. So right-click, click Export, that will give you a file. Then in Turbo Warp, you can hover over here and click Upload Sprite, and then choose the file that got exported. Alright, now we've got this. You'll notice that we have some textures here. We can just delete that sprite. We're going to get our own textures from yet another Scratch Assets project. There'll be a link to that one in the description. And here we are. This is my Assets project. Here we're going to find the sprite called 3D Textures, and then you can just go to the image and right-click and click Export. Then again here, click Upload Costume here, and then choose the file that got exported. Alright, here we are. So you'll notice we have a whole bunch of textures arranged vertically. 18 textures, and they are each 16 by 16. I'll go ahead and make some variables to hold those, in case we want to change them. I'll make a variable called texture size for all sprites, and then a variable called num textures for this sprite only. We can delete these comments. Now there are some modifications we need to make to this, but let's first just briefly go over what it does. So essentially it starts at the top left of the screen and then makes its way down across the screen, scanning what color is at its point. And for each point it adds the color to the scan list. So the scan list is a grid list of sorts. It holds all the rows in order. So starting with the top row, then the row below it, etc. Colors are held in a single number, because that is a way we can switch color. To get the number for a certain color, we can use the RGB values of the color. So we have our red value multiplied by 256 squared, plus our green value multiplied by 256, plus our blue value. And we can see that this will represent all colors because the value of each of red, green, and blue ranges from 0 to 256. There are some more optimizations in the scanning method. If you want to learn more about that, you should go ahead and watch Griffpatch's video on it, which there's a link to in the description. Alright, first of all, when I receive begin scan, I'll set our texture size and num texture variables. Texture size will be 16, and num textures will be, we have 18 textures. Now when we switch costumes here, we switch costumes to our texture sprite instead. We can remove the time variable where we set our time and just delete the time variable. I'm going to rename our scan pass to be not in all caps, just to be consistent with our other variables, as well as the scan list. Generally I like to make our for all sprites variables in all caps, but here where we're not using mini sprites, I'm not going to worry too much about it. Now let's go into our scan block, and rather than setting our Y to the top of the screen, we're going to set it to the top of the texture sprite. So let's start by finding the total height of our texture sheet. That is texture size times num textures. Now we divide this by 2 to get half of it, because the center is at 0. We'll take the floor of this in case this is not an integer, and then finally subtract 1. That apparently just makes the scan a bit nicer. Now for our x, we'll duplicate this. We don't need to multiply by num textures because the width is always just a single texture wide. And we need to go to the left this time, which is negative in coordinates, so we'll subtract all this from 0. Then for our repeat loops, we'll use our texture size times num textures for the outer loop, and then texture size, just plain texture size for the inner loop. Now for our initial scan block, we'll do the same thing. Duplicate these for the set Y and set X, and then again for the repeat loops we'll use the same inputs. So now we've got all that set up, we can hide the sprite first of all, and then back in our main sprite, I'll rename this to be like game or something. You can call it whatever you want. We will need a way to find the color of our texture at a given point. We're going to want to do this after we collide with something, so we need to keep that in mind. We'll do it based on our X, Y, and Z position. So make a block called find texture color at X, Y, Z. Then we do need to know what direction we're moving in, so we'll add a input direction, dir. We can just call it dir. There we go, run with that screen, refresh. Now I'll have the dir be either X, Y, or Z. We need to find the X and Y of our texture. So we'll make variables texture X and texture Y for the sprite only. Now let us find these variables. This will change depending on the dir variable. If dir equals X, so we're moving in the X direction, then we'll want to use our Y and Z variables to find the texture X and Y. We'll set texture X to Z, and then we need to modulo this by 1, because here we only care about what our Z is inside the block. We don't care about what it is in the world, if that makes any sense. Then we multiply this by texture size. So essentially we find the percent of Z across the block, and then we multiply that by the total size of our texture. So if Z mod 1 is like very close to 1, then this will probably be very close to our texture size variable, just as an example. Now we'll set our texture Y based on our Y value. If dir equals Y, we'll change this so we set texture X based on X and texture Y based on Z. Now if dir equals Z, we'll use our X and Y. This is pretty intuitive. X will be based on X, Y will be based on Y. Now that we found this, we can calculate our index in our scan list. So I'll make a variable called texture IDX, stands for index for the sprite only. This will be very similar to our find grid index, so we can actually just duplicate the code from our find grid index of position block. We'll change all the block indexes to texture index. Change our grid list to scan. Change our grid width and height to texture size. Replace our X with texture X. Replace our Y with texture Y. And then for the Z, we can replace this with block -1. Our Z value is sort of which one of these mini textures it is. You could think about them being all stacked on top of each other, in which it would be like a changing Z sort of situation. Now when we set block, we're going to need a new variable to hold this. I'll call it color for the sprite only. We'll set color to item texture index of scan. Now you may remember that our texture scanning starts at the top and then moves to the bottom, but in this situation our texture Y starts at the bottom and then moves to the top. So unless we want our textures to display upside down, we'll need to set texture Y to texture size minus texture Y. So sort of reverse it. The bottom will become the top, and the top will become the bottom. Alright, we are now done with our fine texture color add block. Now we can use it in our move forward block. In the else, when we collide, we will find texture color at for the outer one, which is our X. Actually, we'll use our X, Y, Z inputs for all of these, but our direction will change. For the outer one, it'll be X, and for the next inner one, it will be Y, and for the innermost one, it will be Z. You'll notice, take for example, we move in the X direction. If we collide with something, we don't then move in our Y and Z directions, we just stop there. But if we want our texture finding to be accurate, we need to change our Y and Z as well. So we'll bring this down. We'll duplicate our change Y and change Z blocks, bring them down to here. With our Y, we only need to use the change Z block. And then for the Z, we've already moved in all three directions. And make sure to put these before we find our texture color. Alrighty, now we need to add our color to our view list. That means we'll change our data amount per view pixel to 4 rather than 3 when our flag is clicked. Then on our create camera view block, we'll also add color to view. I'm going to move it before the brightness mod. It doesn't really matter, but I just feel like it's more important, so I'm just going to put it there. That means that in our display view, we'll need to change our change pen brightness to item I plus 3 of view. Then we can set pen color to item I plus 2 of view, which is the color. Now, the very last thing we need to do is when our flag is clicked, we can broadcast and wait begin scan. Alright, now we can run this and see what happens. And look, we've got ourselves a grass block. And it's also a grass block on the top. We can fix that. The important part is that we've got our textures. And they are looking just fine. You'll notice, like, if we turn a little bit, we can see little bits of brown here showing through. That is just an unfortunate consequence of the fact that sometimes we overshoot slightly. But alright, and you can see this block over here that is just plain dirt without any grass. That's the one that we set to 3 here when we placed our block. Alright, now let's get those top and bottom grass textures looking right. I'll go into our fine texture color at, and we can just say if dir equals Y, we'll check if block equals 1. That's our grass block. And if it is, we can set block to 2, which is the top of our grass block. Running this, we now have a lovely green topped grass block. But let's look at the bottom. Aha, that's also green. And that is not what we want. But fixing this isn't too hard. We can just use our change Y variable. If change Y is greater than 0, we're moving up, so we'll set block to 3, which is our dirt block. And otherwise we're moving down, so we'll set block to 2. And moving down would mean we're moving down into the block. Alright, let's run this. Yep, that's dirt on the bottom. Alright, that's looking good. You will notice when we press the flag, we briefly see the texture sheet appearing. We don't actually need to scan our textures every time. We can remove our broadcast begin scan and wait, and this should still work. It's just if we change our textures, we'll need to broadcast that. Let's try placing a log, which is tile number 5. So I'll place block 5 and then choose a position. I'd like it to show our top log face here. We can just do the same thing we did for the grass block. It's even simpler, in fact. If block equals 5, we'll just set block to 6. And this is inside if dir equals Y. Now we have our top and bottom faces. Our last block like this is the crafting table. That's number 12. So if block equals 12, then the bottom face is actually wood planks, which is 11, and the top is number 13. Let's just place that down to test it. Yeah, there we go. Looking lovely. Spiffing, if you might say. Finally, let's take a look at our water tile. That's number 8. I'd like this to animate a bit. And I don't have a very good animation. It's only 3 frames. But you can make a better animation if you want using the same principle. This is just to show you how it's done. In fact, I would greatly encourage you to use your own textures. Just make sure all the variables are updated correctly and it's in the same format of arranged vertically. Alright, for water at the top, I'll just check if block equals 8. Then we can change block. And then we'll use our timer. We'll say floor if timer and then multiply it by 5. Just to make it a bit faster, and then modulo by 3 because we have 3 frames. So this will change block by 0, 1, or 2, which is just what we want. Let's run this. We can see over there our water block is animating. You'll notice some weird coloration here. That's because I think the water tiles are actually a bit transparent in this image. That was not intended, but the world that we had previously rendered was showing through. So when I receive begin scan, I'll just erase all, and this is in the scanner spray. Let's just broadcast this once more to reset our textures, and then we can run it. And the water should be looking normal. Yeah, now we've got a little animation. As I said, it's not a particularly nice animation, but it demonstrates the principle pretty well, I would say. Ooh, also we can fly into blocks, that's kind of fun. Whee! Alright, well, that is it for this episode. This is already so much better than it was last episode. I'm super excited about the series, and I will be traveling next month, so I won't be posting any videos then. So it will be about a month's wait until the next episode in the series. I'm sorry about that, but I will see you then. Have a very nice July, and a great rest of your day. I hope you enjoyed this episode, and goodbye!